Well, welcome to the last lecture in Chemistry 12. Believe it or not, it's finally arrived. There's two topics that we're going to cover today. They're both really short um, and interesting. The first one, as you can see, they're both going to be applications of electrochemistry, really. First one is electroplating, which you guys are probably familiar with already. And electroplating is when we take some cheaper, more basic metal and we want to apply a coating on it, either to protect it or to make it look better, or both. So let's say we have this copper, let's say that, oops, sorry, you can't see that. Let's say that this is a copper medallion. So I'm going to just kind of color this in a bit. So here's this. Copper medallion, and we want to coat it with nickel. You can see we're going to do it with nickel. So in order to do that, you have to have nickel in two places. This has to be nickel, so you have to have a chunk of nickel, and this is copper. Okay, and you're going to put it in the solution. Immerse this in a solution of nickel ion. Well, you say, well, how do you do that? Well, let's just take a, say, 1.0 molar solution of nickel nitrate. Okay, and this goes back to when we talked about solubility, that if we wanted to get some sort of cation into solution, we just hook it up with a nitrate and it'll dissolve. So that's what we do. So in here, we have basically nickel ion in here. The nitrate is a spectator ion, so he is not really of any concern to us. So again, we look at this setup and you see that this is a negative, this is the negative part, this is the positive. So that means we're going to be supplying electrons down this way. Okay? And that also means that electrons are going to be formed from here. So at this point here, at the anode, you're going to get nickel producing a nickel ion, which is going to go into solution, and two electrons, which are going to go this way. Okay? And as the electrons come down here, they will attract the nickel. Nickel will accept, the nickel ion will accept the electrons and form on this side nickel plating. So on this side, you're going to be the opposite. You're going to take the nickel ion from here plus the two electrons, and you're going to form elemental nickel, just like that. That ain't too tough, eh? Okay, that's half the class right there. Okay, thing of beauty, works great. Now the reason why you have this nickel in here is because you have to be replacing the nickel ion that you used from the nickel nitrate in here. If you don't replace it, whatever you put here is going to go, like, let's suppose that instead of putting a nickel strip in, let's say you put in lead. Well, you'll use nickel will begin to plate here because it's already in solution, so it's going to be attracted to the copper medallion. But when you're pulling electrons out of here, if this was lead, you're going to get lead going in here. So you're going to getting lead being deposited on the copper medallion, and you don't want that. So whatever metal you want to plate on, you have to have a solution containing that ion, and you have to have the base metal itself, and then you can plate, and this will just continue to get, this will get smaller and smaller and smaller as the more you plate, and it will grow onto this medallion here. It just continue to go. Okay, so you could plate it until it's completely coated, and then say, okay, time to turn it off. I'm going to save the rest of the nickel for another rainy day, and that'd be fine. But if you continue to plate, it'll just keep on going. Okay, so that is electroplating. I want to look at electro-refining now, but I'm going to actually use a blank piece of paper. So if you don't have a piece of loose leaf, go run and get one right now. Pause the video, go get a chunk of paper, and come back, and we'll set it up for you. Okay? Okay, I am going to assume that you got your paper, and this topic is electro-refining. And what I want to do is I want to actually draw. Okay. Do it this way. Draw this like so. So I'm drawing a beaker, by the way. So and I am going to say that let's suppose I have copper containing impurities. So that means non-copper elements. Okay? Now let's say these impurities are, let's say, zinc impurities. Let's say there's zinc. Let's say lead. I'm going to put this elemental, okay? Let's say silver, platinum, and gold. Oops. Okay. So what I want to do is I want to do two things at once. I want to separate the copper out of the a sample, and I want to collect the good stuff. Now you say, well, what's the good stuff? Well, in my mind, the good stuff is going to be silver, platinum, and gold, because these are precious metals, and they're worth a lot of money, whereas zinc and lead are less so. So let's set this up. Let's say that on this side we have this chunk. I'm going to do it all. Here's the chunk of impure copper, and let's say, and I will need, if I'm going to separate copper out, I'm going to need another electrode of solid copper, because I'm going to transfer it. I'm going to recoat this. I'm going to continue to coat this one. Okay. So here's the this is pure copper. Okay. This is copper with impurities. I'm gonna do little representative color things too. I'm gonna say that here this is zinc, and we are going to have, let's say, this green is going to be lead, and let's say we have silver, and platinum, and gold. Kind of outline this one here because it's hard to see. Platinum and gold. Okay, and so this is going to be, I'm sorry, I need to, this is just a solution, okay? And we are going to hook it up to a wire. So here's the, so electrons are going to be going this way. Okay. Now, based on what you know from electroplating, the first thing is no big surprise. So this chunk, what you should expect is as electrons, so electrons are going this way, and they're coming from here. So the what's happening is the copper, it will gradually the electrons will be taken from this copper chunk and transported around to the pure copper electrode over here. And meanwhile, the copper will just will oxidize into the copper ion and continually be transferred. So it's basically going like this. and this is building up pure copper on all sides as the electrons are supplied. It's just going to keep on building up on you and building up on you. And this is going to get smaller and smaller and smaller. And in the end, it's going to be gone if we run it long enough. So what's going to happen here? How does this work out? Well, to understand how it works out, we actually have to order all the players in descending order of their standard reduction potentials. Okay, so the first one is gold. Now I've got my table next to me, so I'm going to just do this, and so you can follow along on your table if you like, but if you don't, trust me, okay? So the first one is gold 3 plus 3 electrons excuse me, is going to go to elemental gold, and its half cell potential is plus 1.50. Okay, the next one down of these players is platinum, and platinum is 2 plus 2 electrons to produce platinum, and that is at plus 1.20. Silver is the next, single valence, and he has 1 electron, and it'll produce silver. Okay, the guy in the middle, I'm going to put a space here, and you'll see why in a second. The guy that we're dealing with is copper, and copper 2 plus 2 electrons produces copper, element of copper, and he is, oh, I didn't do this one, plus 0.80, and this is plus 0.15. Lead, down here, lead, plus 2 electrons, negative 0.13. And the last guy in the series is zinc, plus 2 electrons, and it goes to ZnO, and this is negative 0.76. Okay, now what's all this is about? Well, to understand how this works, you have to have a general sense of what this table means. What it means is that the guys that are at the top here, the positive voltage means that its preference is to go this way. Okay. The ones at the bottom, their preference is to go this way. So in other words, these guys prefer to be reduced. These guys in the bottom prefer to be oxidized. So if we supply voltage to this, copper, anything that is above copper, anything that is above copper, oh, you can't see that, anything that's above copper, they want to remain as elements. These guys want to be elements. Okay, so that means in their reduced form. That means, like in this case, solid, solid, solid. So their predisposition is to go this way. Okay? These guys don't. They want to go this way. So what that means is that in this situation, these guys want to stay as ions. So this is so cool. This is so cool. I love this. So what does that mean? Well, that means that, as we said, the copper here is going to be plated on here, continually plating. The guys are below, so where's this thing? So lead is going to stay as an ion. It's going to stay as Pb plus 2. Zinc is going to stay as an ion as Zn plus 2. And the guys that are going to fall at the bottom are going to be the gold, silver, and platinum. So you're going to have silver falling out into the bottom. You're going to have gold falling out into the bottom. And you're going to have platinum falling out into the bottom. So now, you've collected some really, really valuable metals worth a lot of money from impure, just as a result of an impure sample of copper. Now it turns out, I do remember the name of the mine. It was copper, what was it? I just had in my head. It's not Brenda Mines, because that's here. Highland Valley. So back in the 80s, it turns out that Highland Valley, and this is near, it's between Lac Lejeune and Merritt. But Highland Valley copper mines, back in the 80s, you guys weren't around, but in the 80s the economy went really south, and so the price of the international price of copper tanked, and so it was not worth their while. They were losing, if they continued to mine for copper, they're actually losing money because their production cost was more than what the price would they could recover from, and so they didn't want to lay off all of their men. So what they did is they went back into their tailings, and basically this is what they did. They electro-refined all of their tailings and their slag and whatnot, and they ended up making enough money to keep the Highland Valley mines open for I don't know how many years. It was at least 3 years, which is amazing. So they made money, actually. They're a copper mine, but they're making money in refining or electro-refining gold, silver, platinum, and precious metals. Wonderful. I'm so pleased with that. So the only thing I can suggest you do, in addition to make this a complete notes, is just to highlight the different colors as we have. So gold. If this is just, you don't have to do this, but I'm going to. Gold, platinum, and silver up top. Below have our lead. Oops. Lead. Now, it's not to say that lead and zinc don't have some value, but comparatively speaking, not as much. Well, beloved, it's been a slice. So, yeah. From here on in, we need to complete all of our Hebden. We need to get ready for the chapter test, which will be forthcoming. After that, we need to have a bit of a conversation, you and I, about what tests you may want to do remedial work for and retest to get a better mark. And because things are what they are, we need to also get ready for a final exam. So the final exam, just we'll talk more later, but the final exam will be taken from all the topics that we've covered from the beginning of the course. The questions, I believe all the questions come from previous chapter tests. So it's everything you've seen before. Big question is, what ones? The test will be presented in the order that you learned it. So the Unit 1 will be first up, Unit 2 will be second, and we'll follow through that way. Okay? But more on that later. Please avail yourself of my office hours, which you'll be learning about. You've already learned about that. And if you need help, I think for the best thing that we can do is to, again, just reiterating, is to let me know in advance what what questions you want me to help you with, so I can be prepared for that. And the likelihood is that I will give you make a video and either send you the video or post the video in Moodle or something. I'm still trying to figure that out. Okay? Love you, bless you, and I will hope to see you soon. Bye now.